Now we're going to look at an interesting function, which is the tangent function. Now, unlike cosine and sine, tangent is not a value that we list on the unit circle. It's actually a ratio of the sine to the cosine. Um, so this is the same thing as sine of x over the cosine of x. Now, another thing that you can think of, it's the slope of the line that we're looking at. So, if we were talking about, 30 degrees or pi over 6, it's this slope here, the slope of the line. This is really useful to think of it in this way because you can kind of predict what's going to happen. So keep these things in mind as we go along the circles. Now, you do not have to be able to memorize these, but what you want to know is what's going on and how could I calculate them if I need to. So we're going to, again, record this on our unit circle. So we've got our degrees and everything here. Now, what I want you to first understand is tangent behaves completely differently because it's a ratio now. Okay, and so I'm going to do. You're going to have to understand some things as you move along why tangent behaves the way that it does. So when we think about 0, which is back over here, the value of tangent at 0, again, is the slope of the line as we move through here. Well, this slope it's a slope of 0. You could also think of this in terms of sine over cosine. Well, the sine is 0, the cosine is 1, so you get that. So the tangent value is 0 here. Now, what's going on at 90 degrees? Well, again, the slope represents the tangent. Well, what's the slope of this line? It's actually undefined. And this can be more easily understood if we think about it in terms of sine over cosine. Well, the sine is 1. The cosine is 0. So if we think about starting at this point here, our y value goes up from that point, but our x value never changes. So the slope is kind of, in a way, like infinite. So what happens for tangent in this value is it actually does not exist. And it has this thing called a vertical asymptote. Now, a vertical asymptote basically represents a place where a function is going to become unbounded, but it's not allowed to take on this value at 90 degrees. So we'll go back and draw our graph a little bit later, but it's important to understand the tangent of 90 is the slope, or sine over cosine, of that angle and the origin. So you can see that it's not going to exist. It's infinite slope, or unbounded. When we go to 180 degrees, again, we can think about our slope. This is, again, another slope of 0. At 270 degrees, straight down, this is another asymptote. And then when we get back to 360 degrees or 0, we're back at another value of 0. Well, that's kind of strange. So how this is worked out. Now, what we want to do is try to figure out what's going on from these points. This is a good part. Now, think about the values of the corners. So right here, right here at 45 degrees, so right in the middle, what's going on is we have a tangent value. Okay, we have a tangent value that is 1, which is the sine over the cosine. Sine and the cosine are the same at this place. And you can kind of see this looks like a slope of about 1. It's right between 0 and vertical. So right in the middle we have this. Well, what happens when we go to 135 degrees? So in between 90 and 180. Well, it looks like it's -1, doesn't it? So, right, it's the opposite slope, right? It's going down as it's moving from left to right. So it's actually -1. Now, when we move to let's say 225 degrees, well, look at this. This right here looks like it has a slope of about 1. Now this makes complete sense because the slope of 225 goes to here, goes straight through to the other side, right? This is a reason why the tangent is the same 180 degrees around a circle, is because it's referencing a slope. So this is why it repeats itself in this manner. And then finally at 315 degrees, we're back again with our slope the same as it was. That's a pretty bad line. Slope is the same as it was at 135 degrees, which is going to be a value of 1. Or negative 1, excuse me. So think about what's going on with our slope. We start at 0. I'm going to do this in red so you can see it maybe a little bit better. Our slope starts at 0. And then it goes up, and up, and up, and up, and up, and up. And then finally, what happens is the slope starts at 0 and goes all the way up to where it's about infinite. And then it's not allowed, but it's not allowed to be infinity. And it's not allowed to exist. Like we can't, it does not exist at 90 degrees. Okay? It's kind of strange. So what happens when tangent, it goes from like 89 degrees. Okay, so let's say 89, then it's not perfect, to 91. So like on the other side. It takes on the same kind of magnitude, but now it's negative. So instead of being a really, really large like a really, really large positive number, very, very, very high slope, it goes to a very, very, very negative slope right afterwards. So the value of tangent now is super, super negative. It's almost negative infinity. So our function actually goes all the way down that way. It's very interesting. Now, as we get back here, it goes up to 0. Now, just like what had happened before, we're at 0. Each successive point, so that's a positive slope. More positive, more positive, more positive, more positive, and then finally up to infinity. It repeats itself again like this curve. Now what happens from 269 degrees to 271? Well, the slope goes from very positive to very negative again. And so we repeat this process again and again and again and again. So tangent has a few things about it that are very unique. Notice that it breaks itself apart. Tangent, because it's a ratio and because there's a function in its denominator, have values that will make it not exist. Anytime where cosine is 0, tangent fails to have a value. So cosine has zeros at 90 degrees and 270 degrees, or pi over 2 and 3 pi over 2. Tangent does not exist in those places. Another thing that is true, there's no amplitude. Now, why is there no amplitude for tangent? Well, there is no max. There's no min. So we can't find the difference and average it. None of that exists. So this is a unique function in that sine and cosine have an amplitude. They are continuous. They have all value. They exist for every value of an angle. But tangent doesn't. Tangent has no amplitude. Tangent has no, no max, no min. So these are really, really important facts as we move along. Think about tangent is special, but you can figure out tangent and understand it without having to memorize everything about it.